This is Algebra 2, Lesson 5-4, Dividing Polynomials. Synthetic division is a form of division that simplifies the long division process by dividing by a linear expression x minus a. Essentially what you do when you use synthetic division is you eliminate the variables until the last step, which makes it much easier to divide. Polynomials can be divided using steps that are similar to the long division process steps that you would use to divide whole numbers. When you factor a polynomial, you're trying to find a divisor of the polynomial that gives a quotient, other than the factor, with a remainder of 0. This suggests that being able to divide one polynomial by another polynomial can help you factor polynomials. So, to divide polynomials other than monomials, you're going to follow the same procedure you did when you divided whole numbers. When your divisor is not a monomial, you will use polynomial long division. But you have to make sure two things happen. You must list the dividend, that's the number being divided, in descending order of the variable. For example, x to the 5th, then x to the 4th, and x to the 3rd, and so on. And you have to use a placeholder of 0 when a power is skipped. For example, if I had x to the 5th, and then the next thing I had was x to the 2nd, I'd have to have a 0x to the 4th and a 0x to the 3rd when I wrote down my polynomial so I could divide it properly. Okay, let's practice. We're going to divide x squared plus 3x minus 12 by x minus 3. And we're going to do this just like we used to do dividing when we were younger. The x minus 3 goes on the outside, and on the inside we have x squared plus 3x minus 12. Since this goes in descending order of a variable, power of 2, power of 1, power of 0, we can write it just as we see it. So x squared plus 3x minus 12. Now, the easiest way to divide is just to think of the very first term. This is my very first term, x here. What do I need to multiply x by to get x squared? Well, I have to multiply it by x, because x times x squared, or x times x gives me x squared. So I will put in an x up here. X times x is x squared. X times negative 3 is negative 3x, just like you divided when you were younger. You divide in and you multiply it by each part of the problem. Okay, so now we're going to subtract. When we subtract, we change all the signs. That's what I tell people to do. To make sure you don't make a mistake, because we're supposed to subtract. A lot of times we forget to subtract by running the negative all the way through. So just change all the signs. This becomes positive. Okay? Now, negative x squared minus x squared is 0. 3x plus 3x is 6x. Now we bring down our 12. Okay? So we divide it in, we subtract it, we bring down, just like you did when you're dividing whole numbers, or decimals for that matter. Now, what do we have to multiply x by to get 6x? Well, we have to multiply it by 6, so I'll put a 6 up here. 6 times x is 6x. 6 times negative 3 is negative 18. Okay. I need to, again, subtract, and when I subtract, I change all the signs. So this becomes a negative, and this becomes a positive. 6x minus 6x is 0, and negative 12 plus 18 is 6. There's nothing else to bring down, so I am done at this point in time. Therefore, dividing x squared plus 3x minus 12 by x minus 3 results in x plus 6, remainder 6. So the quotient is x plus 6, remainder 6. And you can write that remainder as remainder 6, or sometimes you'll see it written like this, x plus 6 plus, and then you'll have your remainder over your divisor. This is an infrequent way to see it written, but I have seen it written that way. Right? It just means x plus 6 divided by x minus 3. It's kind of like changing a improper fraction to a mixed number. You divide in, and then your remainder over your divisor becomes your fractional part. Same exact thing here. Okay, let's do this a couple more times, because this is a new concept for most of you. So if I take 2x squared plus 3x plus 5, and I'm divided by x plus 1. So my x plus 1 goes on the outside. On the inside, 2, 1, nones. There's nothing missing, so I don't need any placeholders, and it's in the right order. So I'll have 2x squared plus 3x plus 5. What do I have to multiply x by to get 2x squared? I have to multiply by 2x. 2x times x is 2x squared. 2x times 1 is 2x. I need to subtract, so I'm going to change all my signs. That's why I circled them, so I know I changed them. 2x squared minus 2x squared is nothing, so 0, or I can just leave it blank. 3x minus 2x is just x. Now bring down. What do I have to multiply x by to get x? I can multiply by 1. 1 times x is x. 1 times 1 is 1. Change all my signs. Right? X minus x is nothing. 5 minus 1 is 4. So this would be 2x plus 1, remainder 4. Here we have x to the 4th plus x to the 3rd plus x squared plus 2x plus 1. And we're going to divide that by x plus 1. Right? Again, 4, 3, 2, 1, none. There's no placeholders needed, and it is listed in descending order. So we didn't have to change the order, and I don't have to put any placeholders in. So I'll put in the x plus 1 here. I'm going to divide that into x to the 4th plus x to the 3rd plus x squared plus 2x plus 1. What do I need to multiply x by to get x to the 4th? Well, I have to multiply by x to the 3rd. X to the 3rd times x is x to the 4th. X to the 3rd times 1 is x to the 3rd. Change all my signs. X to the 4th minus x to the 4th is nothing. X to the 3rd minus x to the 3rd is nothing. So then I'm going to bring down, and I need to bring down more than one term because I'm dividing by a binomial. So I'm going to bring down the x squared plus the 2x. What do I need to multiply x squared by to get x squared? I need to multiply it by x. X times x is x squared. X times 1 is x. Subtract, so I'll change all my signs. X squared minus x squared is nothing. 2x minus x is x. And bring down my 1. What do I need to multiply x by to get x? I can multiply by 1. 1 times x is x. 1 times 1 is 1. So this one has a remainder of 0. So x to the 4th plus x to the 3rd plus x squared plus 2x plus 1 divided by x plus 1 is x to the 3rd plus x plus 1. Now, you can use polynomial long division to find the factors of each polynomial. For example, it's may say determine whether x squared plus 1 is a factor of 3x to the 4th minus 4x to the 3rd plus 12x squared plus 5. To determine whether it's a factor, I'm just going to divide in and see if it ends up to be a factor, and there's a way to figure that out. I'll show you how it's done. Okay, so let's take a look at this here. We're going to have x squared plus 1 on the outside. On the inside, 3x to the 4th minus 4x to the 3rd plus 12x squared plus 5. What do I need to multiply x squared by to get 3x to the 4th? I need to multiply by 3x squared. 3x squared times x squared is 3x to the 4th. 3x squared times 1 is 3x squared. Notice it's x squared, not x cubed, so I have to write it underneath the 12x squared. Because if I don't, I'm not going to line up my like terms. So the 3x squared goes here. Then when I change all my signs so I subtract properly, I will have, bring down the negative 4x to the 3rd, and 12x squared minus 3x squared is 9x squared. Okay. Whoops. Holy cow, I forgot something. Way back here, I don't have an x term. So I need a placeholder of 0x here before I put the 5 in. Okay. Missed that. And you have to make sure that we had a 4, a 3, a 2. We didn't have an x. So that's where this comes from. We have to have our 0x in there. And then plus 5. Or this would never divide properly. We'd be in big trouble. So make sure you put that placeholder in. All right, now, what do we have to multiply x squared by to get negative 4x to the 3rd? Negative 4x to the 3rd. Negative 4x times x squared is negative 4x to the 3rd. Negative 4x times 1 is negative 4x. Well, guess what? I'm going to have to bring my 0x down here so that I can line up my like terms with this negative 4x over here. Okay. Here. Okay. So now when I subtract, I will be changing all my signs. When you subtract, you change all your signs. Negative 4x to the 3rd plus 4x to the 3rd cancels out. 9x squared stays. 0x minus 4x is negative 4x. Then I'm going to bring down my 5. What do I need to multiply x squared by to get 9x squared? I need to multiply it by 9. Multiply by 9. 9 times x squared is 9x squared. 9 times 1 is 9. Change all my signs. And I end up with negative 4x minus 4. My remainder here is not 0. Excuse me, it's positive 4x. I missed that sign right there. Positive 4x minus 4. I missed, okay, the remainder is not 0. Since the remainder is not 0, okay, this remainder here is not 0. If the remainder was 0, then it would be a factor. Since the remainder is not 0, x squared plus 1 is not a factor. So x squared plus 1 is not a factor of 3x to the 4th minus 4x to the 3rd plus 12x squared plus 5. If the remainder would have been 0, then x squared would have been a factor, but since the remainder is not 0, x squared is not a factor. Now let's see if x plus 2 is a factor of x squared plus 10x plus 16. Okay, so I'm going to put in here x plus 2 over here, x squared plus 10x plus 16, 2, 1, none. I'm just going to forget this time. What do I need to multiply x by to get x squared? I need to multiply by x. That gives me x squared plus x. Change all my signs. And we get x squared minus x squared is nothing. 10x minus 2x is 8x. What do I need to multiply x by to get 8x? I have to multiply by 8. 8 times x is 8x. 8 times 2 is 16. When I change all my signs, everything cancels out. I have a remainder of 0. Okay. So, since I have a remainder of 0, x plus 2 is a factor. Okay. So, all of the factors, okay, the factors of x squared plus 10x plus 16 would be x plus 2 times x plus 8. There we have it. Now, there's this really cool thing called synthetic division. To divide a linear factor, you can use a simplified process that is known as synthetic division. In synthetic division, you omit all the variables and all the exponents. By reversing the sign of the divisor, you can add throughout the process instead of having to subtract. It makes your division much easier. It seems a little complicated, but actually it's really, really easy. Synthetic division is sometimes called the method of detached coefficients because you detach the coefficient from everything else. So we're going to use synthetic division to divide 3x to the 3rd minus 4x squared plus 2x minus 1 by x plus 1. Okay. The first thing we need to do is we need to reverse the sign of the constant term in the divisor. Think of it as this. If I have my x plus 1 right here, I have to solve that for x. X would equal negative. So my divisor is negative 1. Okay. Now, what am I going to do is I'm just going to make sure that the dividend is written in descending order, which it is. And all I'm going to use is the coefficients. So I'll use the 3, the negative 4, the 2, and the negative 1. Just the numbers in front of the variables for the constant term. But no, it's kind of like a matrix. When you use matrices, you only use the constant, the coefficients. Same thing here. You're just going to use the coefficients. Now it's a step-by-step process. The first step you always do is you bring down the first number. This number always gets brought down first. Now you bring it straight down. Then you're going to multiply this number by your divisor. So 3 times negative 1 is negative 3. It goes underneath the next one. Then you're going to add. Negative 4 plus negative 3 is negative 7. And then you're going to do the same process again. Negative 7 times negative 1 is positive 7. Then we're going to add 7 plus 2 is 9. 9 times negative 1 is negative 9. Negative 1 plus negative 9 is negative 3. So we have now divided out. The next thing you need to do is once you have finished dividing, then since we divided by x plus 1, and our first term was x to the third, now when we write our quotient gets written starting with the next exponent down. So it's not going to be an x to the third. This is going to be 3x to the second minus 7x plus 9, remainder negative 10. All you have to do is you're going down 1, since you started with an x to the third, or since you divided in, you're now going to have an x to the second. If I would have started with an x to the fifth, this would have been an x to the fourth to begin with my problem. Okay? So that's synthetic division. I'm going to do a couple more problems in synthetic division to make sure you're understanding what I'm talking about. Okay? We're going to divide by synthetic division. I like synthetic division. To me, it's much faster, a lot less space consuming too. All right, we're going to divide 2x to the third minus 7x squared minus 11x minus 20 by x minus 5. So reverse the divisor, so we're going to divide by 5. This goes in descending order, so I'm just going to use the coefficients. 2, negative 7, negative 11, negative 20. Remember, bring down. That's a 2. 2 times 5 is 10. Negative 7 plus 10 is negative 3. Negative 3 times 5 is negative 15. Negative, positive 3. You didn't want to do that. Step back, go back, and this is something that doesn't look right. Okay, so negative 7 plus 10 is positive 3. 3 times 5 is 15. Negative 11 plus 15 is 4. 4 times 5 is 20. Negative 20 plus 20 is 0. So this one divides evenly. So x minus 5 is a factor. And so we can write our final answer here. So when we divide 2x to the third minus 7x minus squared minus 11x minus 20 by x minus 5, we get 2x squared plus 3x plus 4. I find synthetic division to be much easier, a lot less time consuming, and a lot less chance that you're going to make a mistake on something. All right, last problem for the synthetic division for the second. Let's divide 2x to the third plus 5x squared plus 5x plus 6 by x plus 2. Again, reverse your divisor. So the divisor is now negative 2. Only use your quotients. 2, 5, 5, 6, because it's 3, 2, 1, none. Bring this down, that's a 2. 2 times negative 2 is negative 4. 5 plus negative 4 is 1. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 3 times negative 2 is negative 6. 6 plus negative 6 is 0. So the quotient here is 2x squared plus x minus 3. Okay. Using synthetic division, we're going to solve a word problem using synthetic division. The volume in cubic feet of a crate without a cover can be expressed as the product of its 3 dimensions. The volume as its dimensions is x to the third minus 13x plus 12. The length is x plus 4. Find linear expressions with integer coefficients for the other dimensions and assume the width is greater than the height. Okay, so I already know that the length is x plus 4. So if I take this length of x plus 4 and I divide it into what the volume is, because remember, volume is length times width times height, or length times width times depth, however you want to express it. There we go. Right. So I know that if the length is x plus 4, it has to be a linear factor. It has to divide in. So I'm going to take the negative 4 and I'm going to divide it into x, excuse me, not x squared. I don't use the exponents. 1, negative 13, and 12. Bring my 1 down. 1 times negative 4 is negative 4. That's going to be, wait a second, I did it again. Silly me. Just pay attention to what I'm doing. There's no x squared term. So negative 4 comes here. 1x to the third, 0x squared, negative 13x, and then 12. That's much better. Bring my 1 down. 1 times negative 4 is negative 4. Negative 4 plus 0 is negative 4. Negative 4 times negative 4 is positive 16. Negative 13 plus 16 is 3. 3 times negative 4 is negative 12. There we go. I knew it had to be a linear factor. It wasn't going to be a linear factor the other way. Okay. So now I have x squared minus 4x plus 3. Okay. Now, I can factor x squared minus 4x plus 3. I know this because it's the product of 3 is sum of negative 4, so it's negative 3 and negative 1. Okay, product of 3, so of negative 4. I told you factoring was going to come back in, aren't you? That's going to be negative 3 and negative 1. So x minus 3, x minus 1 are my other two factors. Since it said assume the width is greater than the height, since the width is greater than the height, out of all these, since we already have length is 4, my length is x plus 4, because they already told me that. If my width is greater than my height, then my width has got to be x minus 1. And my height then has got to be x minus 3. Okay, so I have my length, my width, and my height. All right. Now, the remainder theorem provides a quick way to find the remainder of a polynomial long division problem. If you divide a polynomial p of x with a degree of n greater than 1, greater than or equal to 1, by x minus a, which is a linear factor, then the remainder is p of a. Okay. Essentially what that means is, if I take and put it into synthetic division, whatever my remainder is what I'm trying to find. For example, you can use the remainder theorem to find the value of p of x. I'm going to use synthetic division to find p of 3. Yes, I could plug the 3 into this entire problem and work it all out mathematically. But for some people, that might actually become a problem because if you get negative numbers, you tend to mess up some of the negative signs, especially with the exponents. So I can do the same thing here. I'm going to find p of 3 by I'm going to divide 3 into this equation. For 3, there's no 2. So yeah, 5 this time. So a 1, a negative 2, a 0 for x squared, a 1 for x, and a negative 1. Okay, bring this down. So 1 times 3 is 3. This becomes 1 times 3 is 3. 3 plus 0 is 3. 3 times 3 is 9. 9 plus 1 is 10. 10 times 3 is 30. Negative 9 plus 30 is 21. Okay, so p of 3, because this was an x to the 4th, this would be x to the 3rd, x squared, x, my constant term, this is my remainder. So p of 3 then is 21. Okay, which might be faster than sticking in to the equation 3 to the 4th minus 2 times 3 to the 3rd plus 3 plus 9, because some of you are 2 minus 9. Some of you would mess up some of those negative signs. I find this to be a little faster and a little bit easier to use. And that ends polynomial 1 division.